So finally we get to 10.7. We can talk about imaginary numbers. See, here's the issue. We've had the square root of 1 before, and in the past we've just said, okay, well that's not real. And we felt comfortable and we just moved on. Here's the problem. Algebraically, it can take that number, square root of negative 1, if I square it. These are inverses. They cancel each other out, leaving us with negative 1. So we go, well, crud, I thought that wasn't real. Well, it's not. It's not really a real answer, but it does show up. As we get into more advanced mathematics, we have imaginary solutions that show up. And the problem is sometimes they're intertwined or mixed with real solutions. And so we need to be able to deal with those imaginary numbers so that we can get the real solutions as well. Okay? So what we did is we said, okay, this, we know it's not real. There is no real number that times itself makes a negative, but maybe we could deal with it if we called it I. What does that stand for? I is the imaginary number. Why? Because if I take that I and I square it, it becomes negative 1. You need to know this. You need to know this. Okay? I and I squared. I is the square root of negative 1. I squared is negative 1. Because what we do is we build on this and we go, well, dang, what's I, if I is the square root of negative 1, I squared is negative 1, what's I to the third? Let's check. I to the third. Well, we just said I squared was negative 1, so this would just be I squared times another I. We can group that. See, what we're going to start doing is we're going to start looking for things like I squareds. I squared can be replaced because I squared is worth what? So negative 1 times I or negative I. I to the third is negative I. Why does that work? Two of them become a negative 1. Third one's left over, so negative I. Keep going. What's I to the fourth? Well, I to the fourth is I squared times I squared, isn't it? Well, group those. Negative 1 times negative 1, positive 1. Why is this a big deal? Because at this point, this pattern resets. Square root of negative 1, negative 1, negative I, positive 1. I to the fifth, I to the fifth, I can pull out a group of I to the fourth. And I to the fourth is just 1. Which means that's really just I. I to the sixth, I can pull out a group of 4, is I to the fourth, I squared. So it's really just the same thing as I squared, or negative 1. I to the seventh is just the 4, which resets. I'm left with 3, or negative I. And I to the eighth, all 4 reset. That's just I to the fourth times I to the fourth. 1 times 1 is 1, and it resets. So after this, we'll go 9, 10, 11, 12. This pattern is going to continue. This right here, I to the first matches the fifth, matches the seventh, matches the 11th. The second matches the 6th, matches the 10th, matches the 14th. Every 4 it resets. And let's see, I already did yellow, so I'll use orange, which is horrendous here, I'm sure. Third matches the 7th, matches the 11th, and so on and so forth. And the 4th matches the 8th, matches the 12th. So this pattern will continue forever. So you don't have to memorize all of this. You just need to know the first 4. You're like, well, that's complicated. Well, okay, put that on your note card. You have all 4 of those down and you know the pattern, then you can figure out any I. For instance, what is I to the 57th? You're like, well, that's not cool. Okay, well, pull out the groups of 4, because every 4 resets. So basically, I to the fourth is 1. So what is 57 divided by 4? I believe that's 19. Because 20 would be... No. See, I can't do math. 15 would be 60, so it would be 14, with 1 remaining. So that's basically I to the 4th 14 times 1I left over. Well, what is I to the 4th? Well, it's just 1, so it's 1 times 1 times 1 times 1. 14 times, that's just 1. What's left over is just an I. Pull out the groups of 4 and figure out what's left over. What is I to the 23rd? Pull out groups of 4. What is 23 divided by 4? 5, with what remaining? So it's really I to the 4th 5 times. 1 times 1 times 1 times 1, but those don't really matter. What's remaining is 3 i's. I go to my table, I to the 3rd is negative I. What is I to the 200th? Well, pull out groups of 4. What's 200 divided by 4? Well, it's just 50, with nothing remaining. So what does that mean? It's I to the 4th 50 times. That is 50 little 1 times 1 times 1 times 1 times 1. 50 times. That's just 1. I to the 42nd. 42 divided by 4. Do not make that 10 and a half. I want to know it goes in 10 times with 2 remaining. So it's I to the 4th 10 times, which is irrelevant, a bunch of 1s, with what remaining? I squared. And what's I squared worth? Negative 1. This is the hardest thing we're doing with the i's. It's kind of the new, kind of big idea. Past this, it's going to get a little simpler, but I just like to get this out of the way. What is the square root of negative 100? In the past, we put no solution. We were done, moved on. Problem is, I can break this apart, and 100 is negative 1 times 10 times 10. Well, there's a group. Out comes a 10. But you're like, well, what do I do with that negative 1? Well, all of this is under a square root, right? So the square root of 100, out came a 10. I now can group this. Why? Because what is the square root of negative 1? We can pull out an I. So it's 10i. That is the solution that's done. You can pull out square roots of negative 1. You can pull out an I. You can actually check this. This is right. How do I know? Well, 10i times 10i should be negative 100. What's 10 times 10? I times I is I squared. What is I squared? Well, I squared is negative 1. There's that table we used earlier. 100 times negative 1 is negative 100. What is the square root of negative 2? Well, negative 2 is negative 1 times 2. Can't do anything with the 2, but I can do something with this. What is the square root of negative 1? Out comes an I. Left inside is the 2. Let's keep going. What is the negative square root of negative 81? Start on the inside. This is negative 1 times 9 times 9. Out comes a 9. Out comes a what? So coming out of this, we will have a 9 and an I. Waiting in the front is that negative, so that it would be negative 9i. The square root of negative 81 is 9i, so negative square root of negative 81 is negative 9i. The square root of negative 32. 32, I believe, is 8 times 4. 2 times 2 times 2 times 2 times 2. Pulling out groups of 2. I see that a 4 comes out, and a square root of 2 is left over. But it was also negative, so there was a negative 1 in front of all that. What comes out? Do not put the I at the end. First of all, it looks like it's in the radical when it's not. Second of all, it is basically being brought out, so we put it up in the front. Okay? So be careful. If you put it at the end and it looks like it's in the radical, you may lose some points for that. Technically, it's not wrong as long as it comes out, but we put it in front. It's 4 times I times root 2. Too far. Come on now. There we go. This is tempting to multiply these together and go square root of 3 times square root of 7, square root of 21. This is utterly wrong, though, because we just saw that imaginary number times an imaginary number is not positive. This is wrong. It's tempting. Don't do it. What is this really? Well, the square root of negative 3, negative 1 times 3, out comes a what? Square root of negative 3 is imaginary. What's the square root of negative 7? Out comes. So I agree that 3 times 7 is the square root of 21, but I times I is I squared. Don't leave it like this. Look at that first table. What is I squared worth? Negative 1 times the square root of 21, or negative square root of 21. Different answer, isn't it? Don't just multiply them together. This is not the square root of 16. This is, negative 1 times 2. So I, oh my lord, go away. There we go. So I root 2. This is negative 1 times 2 times 2 times 2. So 2, an I, and a root 2. We can now multiply these together. I have a 2 in the front. I times I is I squared. Root 2 times root 2 is the square root of 4. We can simplify that. The square root of 4 is 2. And I squared is negative 1. So 2 times negative 1 times 2, how about negative 4 is our final answer. So work through those. Be careful. Let's keep going. What if I have a negative in the denominator? Well, we can still simplify these. What is the square root of negative 75? Looks like 3 times 25, 3 times 5 times 5. What can come out? A 5. An I. Inside is the square root of 3. Over. What is the square root of negative 3? The only thing that comes out there is an I, and we're left with a root 3. What do? Start to simplify this. The i's can cancel, the root 3's can cancel, and we're left with just 5. Put out the negative I, pull out the i's, and then simplify what you can. You do have to sometimes rationalize the denominator. We've done this before. So this is very tempting to go, okay, that's just 5 over, square root of 25 is 5, the square root of negative is I, so it's 1 over I. That is not done. What's the issue? Why is that an issue? Because I is equal to the square root of negative 1, so we have a radical in the denominator. How do we deal with that? Well, just like we did before, if it's being multiplied, or if we have a square root on the bottom, I can just multiply the top and bottom by the same thing. On the top we get I, on the bottom I get I squared. What does that do for us? I squared can be replaced as negative 1. So I divided by negative 1, or negative I. What if I have I to the negative 9th? It follows our exponent rules. So it becomes 1 over I to the 9th. I would pull out groups of 4 again. So I would turn this into 1 over I. Why? 9 divided by 4, I get 2 groups with 1 left over. Those 2 groups, that I to the 4th twice, are just a 1. They cancel out. So 1 over I, once again, top and bottom, by I over negative 1, or negative I. So that's a choice how we would do that. There's a couple ways of doing that. That's the way I would encourage you guys to think about it. What if I had I to the negative 11th? Well, 1 over I to the 11th. I would pull out groups of 4, 11 over 4, 2, with what? 3 remaining. This is the same thing as 1 over I to the 3rd. I would look at my table and go, well, I to the third is just 1 over negative I. Still not liking that. Rationalize top and bottom. I over negative I squared. That becomes negative 1 times negative 1. I over positive 1, or just I. You have another option with this. I could have taken this, and this is kind of different, and a lot of students don't like this, but remember, it's really easy to group i's in groups of 4. So this already had 3. What if I just gave the top and bottom one more? Well, that would be I over I to the 4th, or I over 1, or just I. So that's another option. Normally with radicals, we just multiply by itself when we just have a radical down there. But the idea is I could make 4 i's and it would simplify pretty easily. That's just kind of how i's work. If that bothers you, don't do it that way. Now on to some of the easy stuff. We can add and subtract. We'll treat this just like a variable. So we can distribute the negative. 7 plus 3i minus 4 minus 2i. What do we combine? The 7 and the 4 make 3. 3i minus 2i is just I. Somebody's wondering, why am I not putting that I first? Well, I'm treating it like a variable, but it is not really a variable. It is a square root of negative 1, and we generally put the radicals at the end. Okay? If you put I plus 3, I will not mark you wrong. I'm just telling you that that's weird. We don't do that. We put the imaginaries at the end. We put the crazies at the end. Okay? Onward. We can add, we can subtract, we can multiply. So we need to know how to distribute this sucker. 7 times 4, 28. 7 times 2, 14i. 3i times 4, 12i. 3i times 2i, 6, plus 6, I squared. Now normally we would just combine like terms and be done, but this is a little different because I squared is something special. I squared is the same thing as negative 1. So I'm going to replace that with a negative 1. So really it's 28 plus, what is that, 26i, and 6 times negative 1 minus 6. Those can combine, so it's really 22 plus 26i. So it's just like our distributing that we've done before, but every time I see an I squared, you got to catch that can be replaced with a negative 1. 2 times 1 is 2, minus 10i, plus 3i, minus 15 I squared. What is minus 15i squared? That's minus 15 times minus 1, which becomes plus 15. So when I combine my like terms, 15 and 2, make 17, 10, negative 10 plus 3 minus 7i. And that's how I would put that. When you get the I squared, replace it with a negative 1, multiply it, and then combine like terms. What if I have a 5 plus 2i in the denominator? I cannot just multiply the top and bottom by I. We already saw that in the last section. Why not? That would fix this one, but it would put another I there. So it doesn't work. So what can we do? Well, use the conjugate. If I have an A plus BI, we'll multiply by an A minus BI. If I have an A minus BI, we'll multiply by an A plus BI. Multiply by the conjugate. Since this is 5 plus 2i, I'm going to multiply by the conjugate, 5 minus 2i. Top and bottom. This is going to get a little messy, so I'm going to deal with these separately and kind of bring them together. So I'm going to deal with the top separately and go 8 times 5 is 40, minus 16i plus 45i minus 18i squared. Okay. Combining like terms. Well, first of all, I'm going to replace that with a negative 1. Those two multiply to make a positive 18. So 40 plus 18, how about 58? plus 29i. That's the top, all over. Let's deal with the bottom. 5 times 5, 25, minus 10i, plus 10i, minus 4i squared. The I squared can be replaced as a negative 1. Negative 4 times negative 1, about plus 4. 25 plus 4 is 29, and negative 10i plus 10i zeroes out. That was the goal. So this is all over 29. Now, it's tempting to leave it like that. If it can be simplified, you need to. And unfortunately, 58 and 29 are both divisible by 29. So really, it'd be 58 over 29 plus 29i over 29. So how about 2 plus I? We're almost done. What if it's a single I in the denominator? Just like we did before. I don't need to do a conjugate this time. We would just multiply the bottom by I. On the top, when this distributes, gives us I plus I squared all over I squared. That gives us I plus 1 over negative 1. Bring the negative up and distribute it. So how about negative I minus 1? I'm fine with that answer. Technically, we normally put the crazies at the end, so negative 1 minus I would be generally the way we would see it. I'll accept either of these, but that's it. This is not that hefty of a section. The scariest thing is dealing with the I's, so just be careful. Let me throw a couple more out there of what I think is the harder thing. If I had, let's just say I to the I to the 18th. If I pull out groups of 4, I'm left with 4 remainder. This is all I really care about, because this basically means that this is I squared. If I went to my table and I told you there was a pattern, it was I squared, the next one was I to the 6th, I to the 10th, I to the 14th, I to the 18th. See? These are the same. These are all the same. So I'm basically pulling out those groups of 4 and figuring out what's left. And then I squared is negative 1. I to the 15th, 15, pull out groups of 4. I'm really only worried about the 3 that are remaining. Why again? I to the 3rd is the same thing as I to the 7th, I to the 11th, I to the 15th. I'm pulling out those groups of 4 because every I to the 4th is a 1. So what are we left with here? It's I to the 3rd or negative I. What is I to the 0? Pretty much anything to the 0. It's still 1. Don't freak out about that. How would I do I to the negative 20? Well, I would rewrite that as 1 over I to the 20. Take out my groups of 4. 20 divided by 4, there's really none remaining. So this is just 1 over 1 or 1. That is, I think, the hardest thing in this section. Get some practice on it. Should be an easy last bit for the test, but kind of culminates and then adds a couple new things. But let me be clear. Past this chapter, we are not going to have a solution that is not real anymore. We are going to not say no real solution. From now on, you have to put your answers in terms of I. So please be careful with that. If you just tell me, oh, square root of negative 2 is not real, you are going to be getting 0 credit on this next test and on chapter 11. So you need to know that we are going to now be dealing with these.